everyone. So today we're going to do lesson 3.2, which is a review of angles of elevation and depression and solving right triangles. So the first thing I want to talk about with angles of elevation and depression is about how they're formed. So you always start with this horizontal line of sight. It doesn't necessarily have to be a line of sight. Sometimes you're measuring from an object or the ground, but regardless, you're always starting with this horizontal line. And then your eyes or the object is looking up or it's looking down. And that is what creates this angle of elevation or this angle of depression. So if you're starting at a horizontal line and we're going up towards something, that generates an angle of elevation. Whereas if you're starting at a horizontal line and then you're moving down to go to something, that is what creates this angle of depression. And I can tell you early on that students usually do not struggle with this angle of elevation. It's usually this angle of depression that gives people a little bit of trouble because they want to put the angle here because it feels natural, but it's not. It's going to be this angle here. So we'll take a look at a good amount of examples so that we all feel comfortable with that angle of depression. So first, angles of elevation. So here we have another visual for you, starting with this horizontal line and then looking up to this line of sight. That creates an angle of elevation. So here we have an example. A surveyor is standing 50 feet from the base of a large tree. I'm not a great artist, so you'll see that my surveyor is here. It's just S in a circle. There's a surveyor. From the base of a large tree, got a large tree. The surveyor measures the angle of elevation to the top of the tree is 71.5 degrees. So you can see my horizontal line starting as the ground, and they've got this measurement to the top of the tree, this angle of elevation right here, as 71.5 degrees. And we want to know how tall is the tree, the height of a tree. So I'm going to estimate about right here is the top of the tree. So I know this horizontal distance to the ground is going to be the same as this horizontal distance to the ground. So I generate this right triangle using this vertical distance with the ground to get the right angle, and I want to know the height. Well, think about what you know. You now know trig functions and how trig functions and angles of trig functions relate to the side lengths of a right triangle. So if I'm looking at this 71.5 degree angle right here, this is my angle in question. I have got, all right, let's see, I want to know H, and H is the opposite side. And I know this 50, and that is my adjacent side to this angle. So I think, what trig function deals with opposite and adjacent? There's two, tangent and cotangent. Well, my calculator can do sine, cosine, and tangent. I have a TI-84, and you're going to need a TI-83 or 84, 89, Inspire, some of those. And you'll see that sine, cosine, and tangent are functions that are already built in. So we're going to stick with using those three trig functions. So I can set up a trig equation. I know tangent of 71.5 degrees for this triangle is equal to the opposite side. I don't know what it is. I'm calling it H. Over the adjacent side, which is 50. And now I can solve for this equation by multiplying by 50 on each side. So I have 50 times tangent of 71.5 degrees equals H. And now I'm just going to use my calculator to find what tangent of 71.5 is. It's really important that you make sure you're in degree mode. If you click mode on your calculator, you'll see that if you have not done any adjustments with degrees and radians, it's going to be in radian mode. And we're going to discuss what a radian is in section 3.4. But for right now, we're only going to work in degrees. So make sure you're in degrees, since my angle measures in degrees. And I'm just going to type in tangent of 71.5 degrees times 50. And I get H is equal to 149.43. And since 50 is in feet, my height will also be in feet. The units are important. So there's a first example using an angle of elevation. Now let's look at an example using an angle of depression. So here I have another visual for the angle of depression where you start out with a horizontal line, and from that horizontal line, if you're shifting down to a line of sight, that is what's creating this angle of depression. So here I have an example. It says, a salvage ship sonar locates wreckage at a 12-degree angle of depression. So here you have my ship, my salvage ship's sonar right here, starting with a horizontal line, shifts, looks down towards some wreckage. Here's my wreckage right here, and that angle is 12 degrees. So the biggest mistake is that people really want to put that 12 in this slot right here. Let me write it out. So they really want to put the 12 degrees right here. That's the biggest mistake. It is up here. Now what you could do is you have 12 degrees here. You could say, all right, well, I know that these two angles right here have to form a right angle. And so I can take 90 minus 12 and I can say, all right, well, I know that angle is going to be 78 degrees. That's fine. But you can't put the 12 in the wrong spot. So it says a diver is lowered 40 meters to the ocean floor. How far does the diver need to walk along the ocean floor to the wreckage? So you can see here where the diver is lowered down in my picture, 40 meters, and I want to know how far he's got to walk. So you have a couple of options here. What I would probably do is I would probably just use that 12 and create a right triangle here. I know I have a right angle here. I've got this 12 degrees, and I know that if this is 40 right here, this distance has to be the same as this distance right here. This also is going to have to be 40 meters. So here's the triangle I'm using once again. And if I want to know how far he's walking across the ocean floor right here, well, that's got to be the same as this right here. So I'll call it X. So again, if I'm using the 12, I have this side, that's the opposite angle, and I want this side, that's the adjacent. So it looks like I'm using tangent again. I've got tangent of 12 degrees equals 40 over X. Now this one's a little more complicated. I gotta get the X by itself, but it's in a denominator. So I'm gonna multiply by X on both sides to get it out. So I have X times tangent of 12 degrees equals 40. And now, since X is being multiplied by tangent of 12, I'll divide by tangent of 12. So I have X is equal to 40 divided by tangent of 12. I'm going to plug that in my calculator, and I get 188.19, and I'm in meters this time. So there is an angle of depression problem. I also want to point out that if you had not used this triangle that I used, if you had used the 78 degrees right here, using this triangle, your setup is very similar. Here's your 78 degrees, but now X is your opposite side, and 40 is your adjacent to this angle. So you'd set up tangent of 78 degrees equals X over 40, and that equation is easier to solve. You just multiply by 40 on both sides, and when you plug that in your calculator, look at that, you get 188.19 meters. Same thing as you got up here. So now what I want you to do is pause the video and try this next problem on your own. It says, according to a Chinese legend from the Han Dynasty, General Han Jin flew a kite over the palace of his enemy to determine the distances between his troops and the palace. If the general let out 800 meters of string and the kite was flying at an angle of elevation of 35 degrees, how far away was the palace from General Han Jin's position? So pause the video and give this problem a try. Okay, so let's go through this problem now that you have already completed it. So here's the picture I drew. So you can see I have the general standing over here, probably with his troops behind him. My horizontal line is just the ground. He lets out his kite, and of course the kite is going to fly up over his palace, so I have this angle of elevation. And they said he let out 800 meters of string, so it's important that you recognize that that 800 meters is the diagonal of this right triangle. So I have my palace, and I'm creating this right angle with the kite right here. So when I'm looking at the angle that I have, I want this right here. I want to know how far away the troops need to go to get to the palace. And that's my adjacent side. And then I also have my hypotenuse, my diagonal, up here. So which trig function deals with adjacent and hypotenuse? And it is cosine. So I have cosine of 35 degrees is equal to my adjacent over my hypotenuse. And since my unknown is in the numerator, this one's going to be pretty easy to solve. I'm going to multiply by 800 on both sides. Put this in my calculator, and we will find how far away they are from the palace. It looks like they are 655.32 meters away from the palace. So hopefully you all had that answer and you didn't have much trouble doing this problem. All right, let's look at this next one. It says, the angle of depression from the top of a 150-meter high cliff to a boat at sea is 7 degrees. So first, let's take a look at this picture. You can see that from this horizontal line, always starting from a horizontal line, down to a boat, that angle of depression is 7 degrees. That's what you're seeing in the black. How much closer to the cliff must the boat move for the angle of depression to become 15 degrees? So if that angle of depression gets larger, becomes 15 degrees, well, that means it's closer to the cliff. And they're asking me for this distance right here between, I'm going to say B sub 1 and B sub 2. So since I don't have a right angle being created with this triangle, let me highlight it for you. This triangle right here, there's no right angle formed. I'm not going to be able to solve for this distance right away. I'm going to have to use right triangles. So what I've got is I've got 2 different triangles here that I can use. The first one is right here. And what that's going to allow me to find is this distance, right? Let's highlight it a little darker. This distance right here is really what I want. I want to know how far away is that boat originally from the cliff. So that's the distance that I want. I know that this vertical distance has to be 150 meters since that's how high the cliff is. So what I'll do is I'm going to come off to the side just so my picture doesn't get too messy. I have a 7-degree angle of depression. I know this opposite side is 150 meters, and I want to know this horizontal distance right here. And that'll give me how far away the boat is originally. It looks like I have the opposite side, and I want the adjacent side, so I'm going to be using tangent. If you wanted to, you also could, and I think I'm going to do it this time. Since I have a triangle, right triangle, I know 90 degrees and I know this 70 degrees. I know this angle down here has to be 20 degrees. And I think I'm going to use that 20 degrees because if I use this 20 degrees, then my opposite side will be in the numerator, and that's going to be easier to solve algebraically. So I have opposite and adjacent. So tangent of 20 degrees is going to be x over 150. And then I just multiply by 150. Use my calculator. And you get x is equal to 54 point, I'm going to round to 6 meters. So that's how far away the boat is originally. Now if you did not use the 20, and you used the 70 right here, you had an equation that said tangent of 70 is equal to 150 over x. And so all that did was that required you to multiply by x and then divide by tangent of 70. And if you did that, we should have got the same thing. When you take 150 divided by tangent of 70, I'm putting it in my calculator now, just to make sure and check behind myself. Yep, we get the exact same thing as I got right here. All right, so now what I'm going to do is I'm going to be using that 15-degree angle, and that'll give me the position of the boat after it's moved a little closer. So if I look at this triangle right here, same thing, the vertical distance is 150, but now I'm finding this distance right here. Let's call it y. So I'm going to draw another representative triangle. This is now 15. Oh wow, that's 7 degrees, not 70 degrees. That's unfortunate. Gotta go back and change that. My handwriting, man. Okay, so this is 7 degrees. So this would not be 20. Okay, gotta go back. I'm sorry, guys. So when I take the 90 minus 7, I'm getting 82 or 83. This should be 83 degrees. So this distance is probably going to be a lot longer. So if I take 150 times tangent of 83, oh yeah, I get 1,221.65. Let's round to 7 meters. And again, this would be tangent of 7 degrees here. Let me just double check and make sure. I would have 150 divided by tangent of 7. Yeah, I still get the same thing. So I'm sorry about that, guys. When I read my picture, this is 7 degrees, not 70 degrees, like I had read that whenever I went back. Okay, so sorry about that. Hopefully we're all good with that part. So now, with my red triangle, I got 15 degrees. I know this vertical distance is still 150 meters. And now I called this y, just because it's a different distance. It should be shorter because the boat's moving closer to the cliff. See, again, you have options. You can use the 15, or you can take 90 minus 15, and you can use 75 right down here. I think that's what I'm going to do. I think I'm going to use this. Again, it just makes the algebra a little easier. So I have the opposite side and I have the adjacent side right here. So I'll have tangent of 75 degrees equals y over 150. You're multiplying by 150 on both sides. So I have 150 times tangent of 75. And I get 559.8 meters. If you used the 15, you would set this up a little differently. You'd have tangent of 15 is equal to 150 over y, and then you would have to multiply by y and divide by tan of 15. So when you put in 150 divided by tangent of 15, you would get the same thing. So we're all set, same thing. All right, so now think about what you're asked to find. And I think this is going to be easy to set up just with a simple segment up here. I'm going to do it over here. So here you have the cliff. Here's the boat's original position, and here's the boat's second position. You know, originally with that angle of depression at 7 degrees, you found that distance to be 1,221.7 meters. Then you found the second position when it had an angle of depression of 15 degrees to be 559.8 meters. So what they're asking you to find is the difference between the first position and the second position. So I can just use that segment addition postulate and subtract these two distances. Giving me my final answer of 661.9 meters from the first position to the second position. So this was a pretty intense problem here because we couldn't solve with just one triangle. We had to use two different triangles. Let's take a look at the next one. To approach runway 17 off the Ponca City Municipal Airport in Oklahoma, the pilot must begin a 3-degree descent starting from an altitude of 2,714 feet above sea level. The airport's altitude is 1,007 feet above sea level. How far must the airplane fly during its descent? Find both the ground distance and the actual distance. So it looks like they want, if I were to draw what they're asking for, they're going to give me this altitude, but they want this ground distance to get to the runway or the airport, and they also want that actual distance, that would be the vertical distance. So they want both x and y. So I've got this angle of depression of 3 degrees, which means if I take 90 minus 3, I know this is 87 degrees right here. Now they're saying that he's at an altitude of 2,714 feet above sea level, but the airport is also above sea level. So if I'm drawing sea level down here, what I would have to do to get the actual height to the runway, I need to subtract those two numbers. So if I take the 2,714 minus the 1,007, I'm going to get that vertical distance that I need of 1,707 feet. All right, so now let's just go ahead and choose what I'm going to find first. Let's find x first. So if I'm going to find x first using this 87, and if that's 87, I know this is 3 degrees. I could use that too if I wanted. I want the opposite side, and I have the adjacent side, so I'm going to use tangent. So tangent of 87 degrees equals x over 1,707. Multiply by this 1,707 on both sides. And let's find what that horizontal distance is. I get 32,571.5, and I am in feet. All right, now let's solve for y. If I'm solving for y using this angle, well, I have the adjacent side, and I want the hypotenuse, so that's going to require a cosine. So I'll have cosine of 87 degrees is equal to 1,707 divided by y. So I'm going to have to multiply by y on both sides, and then I'm going to divide by cosine of 87. So I get 1,707 divided by cosine of 87, and I get 32,616.2 feet. And it should be a little more because it's the diagonal versus the ground distance. All right, I believe I've got 2 more examples. And they are not word problems. These are just of solving right triangles. So anytime that you are given the direction to solve a right triangle, that means find all the angles and all of the sides. So one thing that's important whenever you are looking at angle measures, notice that angle measures are usually in capital letters, and then the side that is across from it is the corresponding lowercase letter. So you have angle A and side length A across from each other. Angle B, side length B across, angle C, and side length C. across. Capital versus lowercase letters. All right, so let me erase this. And then let's get to work. So first, what I like to do is I like to outline the angle measures and the side lengths, and I like to write in what I've already been given. So here I've been given angle measure A is 28 degrees. I've been given side length B is 15 units. They don't give me a unit. And then angle measure C is 90 degrees. And now I'm going to use those to solve for the others. So I know that angle A and angle B have to add up to be 90 degrees. So if I take 90 minus 28, I get angle measure B is 62 degrees. Now to solve for, let's solve for side length A, I'm going to use this 28. I want the opposite side, and I have the adjacent side. So I'm going to use tangent. Tangent of 28 degrees is equal to A over 15. So multiply by 15, and I'll get side length A. I get 7.98. And now let's solve for C. Using here, I've got the adjacent side, and I want the hypotenuse. So I'm going to have to use cosine. Cosine of 28 degrees is equal to 15 over C. So I'll multiply by C on both sides, divide by my cosine of 28, and let's see what we get. 15 divided by cosine of 28, I get 16.988, so 99. And that's it. Notice that I used that 28 degrees both times, and you could have used the 62 if you wanted to use the 62. My advice is always to use what you're given, because if you were to accidentally subtract wrong there and you use the wrong angle measure, in this case for angle measure B, then you're guaranteeing that your other side lengths are not going to be correct. And I know I usually give a lot of partial credit on that because it's a pretty tiny mistake, but not everyone does. So just rather be safe than sorry. All right, go ahead and try this problem on your own and come back and check your work when you're done, and then that'll wrap this lesson up and you'll be all set to do problem set 3.2. So go ahead and pause the video and give this problem a try. Okay, so hopefully you can check your answers here and you got everything that I got. So you can see that I should have done this. Here are all the things you had to solve for. The A and the B and the blue and angle A, and the things in the red were given to you. And you can see your work here. I was able to use sine and cosine and pretty easily solve for side length A and B. So now you are all set to do that problem set.